Welcome back to my YouTube channel. In this video we're going to see how we should solve this integral using Feynman's method of integration. So now, first I'm going to define f of a to be this integral from 0 to infinity arc tan of a tan squared x over x squared dx, and if I find f of 1, I'm going to be getting the integral from 0 to infinity of arc tan of tan squared x over x squared dx. Now, my f of a, if I take the derivative of that, it's going to be f prime of a, and the derivative is going to move inside this integral and become a partial derivative. So I'm taking the partial derivative of arctan of a tan tan squared x over x squared dx. Therefore, my f prime of a is going to be integral from 0 to infinity of 1 over x squared times 1 over a squared tan to the 4x multiplied by, zoomed out a little, multiplied by tan squared x dx. So this is going to be my integral now. And I'm going to write this f prime of a as sine squared x cosine to the power of negative 2x over x squared a squared 1 plus, it's going to be 1 plus, write it correctly, x squared times 1 plus a squared tan to the 4x dx. So this is according to the chain rule and the derivative of arctan. Now if I sort this thing out here, the integral from 0 to infinity is going to become sine squared x over x squared cosine squared x multiplied by 1 plus a squared tan to the 4x dx. Now we need to do a little bit of substitution here. I'm gonna let t be equal to tan. I'm gonna let t be equal to tan x, and t, when it's tan equals to pi over 2, equals to infinity. Equals tan of what did I do wrong here? Oh, yeah, I got it. First, we gotta absorb this sine squared x over x squared according to our integral formula to this. So it's gonna be the integral from 0 to pi over 2. It's gonna become 1 over cosine squared x to 1 plus a squared tan to the 4x. I forgot the rule of this formula. If somebody knows, please let me know in the comments. It's going to be f prime of a. Now I can define t to be equal to tan x, and my dt is going to be secant squared x dx, which my dt is 1 over cosine squared x dx. So now I'm going to do this substitution here. F prime of a is equal to the integral from 0 to infinity of 1 over 1 plus a squared t to the 4 dt. So you can go ahead and try to solve this integral, but I'm going to do the rest for you. I'm going to do another substitution. I'm going to say u equals root at, thus du equals root u dt, and dt equals du over root u. And if I write the f prime again, f prime of a is going to be the integral from 0 to infinity of root u to the negative 1 du over 1 plus u to the power of 4 du, which is going to be, it should be root a. I wrote it incorrectly. Yeah, and u to the power of 4 equals a squared t to the 4. So I can move 1 over root a here, the integral from 0 to infinity. And it's going to be du over 1 plus u to the 4. And there is a general solution for this integral from 0 to infinity of x to the s minus 1 over 1 plus x to the k dx, which is equal to pi over k cosecant of pi s over k. And in this case, s equals to 1 and k equals to 4. Thus, my f prime of a equals 1 over root a pi over 4 cosecant pi over 4, which is cosecant of pi over 4 is 2 over root 2, which is going to be 1 over root a pi over 2 root 2. And if I take the integral here, my f of a, take the integral here, is going to be root a pi over root 2 plus some constant of integration. And if I let a be equal to 0 and equate it to f prime of f of a, I'm going to find that c, the constant of integration, is 0 here. Thus, my f of a is root a over pi over root 2. And we find the constant of integration by setting it equal to the integral. The integral here, arctan of 0, if we equate it to 0, it's going to be 0. The whole thing is going to go down to 0, and the c is going to be 0. I said if I find the f of 1, I mean, I've actually found the integral of mine, which is arctan of tan squared x over x squared, the integral from 0 to infinity dx, and my f of 1 is pi over root 2. And the integral here has an exact value of pi over root 2. If I rationalize it, it's going to be pi root 2 over 2. So this is the form and exact value of the integral that I have here. That was a little bit of work, but hopefully you were able to understand it. Thank you for watching this video. If you have any questions, please let me know in the comments, and I'll see you next video.